All right, hello, folks. Welcome, everybody. Thank you all for making it out. Day 3 of the Nagios World Conference. My name is Emmett. I'm the announcer today. And up next, we have Anders Hual, founder and senior consultant at Ingby. Go ahead, give him a big round of applause.
Thank you very much. And thank you, Emmett, and all of your colleagues to making this conference so great. It's always a pleasure to be here. Well, the presentation today I've called Why Dynamic and Adaptive Thresholds Matters, and especially why it matters in the scope of Nagios monitoring, of course. I was planning to call this presentation maybe why is static thresholds not enough? And that is really the essence of this presentation, to show you a little bit of a different type of capabilities that you may be needing when you're dealing with thresholds. Like Emmett already said, my name is Anders Hual. I work for a Swedish-based consultancy company out of Stockholm. And we do mainly development, project management, operation stuff. And we work predominantly in the financial and transportation industry. Much of the things that I will present you today is something that we have put into a project called BizCheck, which is sort of an add-on to Nagios that will have implementation of much of the stuff I will talk about today. And this project is fully open source, GPL, and has been sponsored very much from DHL in Sweden, in the Nordic area. So giving them some credit to understand that open source code can be beneficial even if you are a big commercial company. It took some time to convince them, though. Well, let's start out with thresholds. From my point of view, thresholds is really the most essential part in monitoring. If we didn't have any threshold, it wouldn't be monitoring. It would just be we measure stuff and we put them on graphs. But the threshold is really what kicks off everything that has to do with alarms and the notification process. So it's really key to get them accurate. So I mean, the threshold really defines the boundary of what we expect as a proper behavior of the thing we monitor. And if that breaks, we get a failure if we break that threshold. And what we typically do, we define thresholds like the thing I'm monitoring should be above a threshold, or under a threshold, or it should be in some sort of interval of a threshold. But exactly as this picture is showing, the type of threshold we define in Nagios, for example, is static. So we say for all time until I change it manually, it should be 20 tons. This is the threshold probably for a bridge somewhere. And this is really the whole problem, because it's not enough, from my point of view, or what we have experienced working with customers, to have that type of limitation a static threshold is. And the limitation is basically that the thing we monitor is not static to its nature. It varies. It varies over a day period, the load of CPU, or how much rows we have in a table, or how many orders we get into a system is different over the whole period of some time period. And typically a day is the time period we typically work with. What we tend to also get if we have this sort of static, very sort of non-very granular thresholding, we get typically too few alarms or too many. And typically when we get too many alarms, what do? We change the threshold so we don't alarm that much. And typically what you get if you have something you're monitoring that have a very high variation, you set it to the max or to the mean, but it's not really catching everything in between there. So you need to be able to have a finer granularity on your threshold. The other thing we have seen Nagios is great. We love it. We all love it here. But from a design point of view, what I've seen is that the sort of design we have with the check commands is we give all the responsibility to the check command to do everything. It's collecting the data, and it's also evaluating if the collected data is in the threshold boundaries or not. And that check command is typically kicked off, doing its job, and then dies. So everything that's going on is very much in its own context. So you don't have anything that are like historical data that you can use to calculate your threshold from. And also with the design we have with this sort of check commands is that the most, we're only considering what I'm currently retrieving from what I'm monitoring. So I'm just in that scope. And then if I need to have something that this thing that I'm monitoring is depending on something else, especially from a threshold point of view, I don't have that capabilities. I mean, we can all write code, so now many of you think, well, sure, I can write that in my check command. And that's true, and that is more or less what we did. We wrote a really complicated check command to do this. So what I'm gaining at here is that we need to have something that is more dynamic. Exactly as this speed sign tried to give you an impression of is, we can change the speed that we communicate to the driver on the road depending on some circumstances around it. It's not always 60 miles per hour. It's not always that threshold. Depending maybe on the time of the day, I want people to slow down because I know it would be more traffic, so I decrease the speed limit. Or I discover we have a traffic jam in front of us or a traffic accident. We also need to decrease that threshold or change it. And exactly the same thing we want to have in monitoring, or that's my point anyway. To try to give you some feeling what I mean here is I will try to give you some examples. And let's start with the first example. Here we have some sort of database table that is get filled and removed stuff from. And I want to define a threshold that it should not be bigger than 5% of the maximum number of rows size it was in the table yesterday. To be able to solve this, we need to, first of all, track how much what we collected, how many rows it had in that table yesterday, store that somewhere. And today, when we make this we're doing the monitoring and checking for it, we need to retrieve the maximum value we had yesterday from in some sort of mathematical evaluation, max function, and multiply with 1.05 to get that this table size should be below that threshold. So that would be my threshold calculation. And this show we need to have access to historical data. We also need to apply some mathematical or statistical functions when we're calculating thresholds. The next example here is that we have some sort of system where we have a number of online users that should not be more than 10% higher than the average of the number of online users that we had for the last data points when we collected how many online users it was. So let's say we have an average, we have 5 minutes interval between collecting them. That means I want to look back at the latest 50 minutes to understand how much online users I had. And again, we need to store the data that we collect. The hard drive is a picture of storing data. We need to store it somewhere. And then we need to retrieve that list of the historical data of how many online users we had for the last 50 minutes, which would be the 10 data points from X0 to X9, and calculate the average and multiply it with some sort of number, in this case 1.1, to calculate that we don't have a threshold, we don't have number of users over that threshold. Let's look at the third example. In this case, we have more business. I hope it doesn't scare you off. But here we have some sort of application we're monitoring. And we want to understand, and we want to have an alarm if the number of orders we get into the system, let's say we have some EDI flow in with orders, if the number of orders with some sort of errors in the data is about 5% of the total number of orders that we have received, I would like to be